Here's a second-year solid mechanics problem which explores the idea of asymmetrical bending. So for this problem, we don't actually look at the stresses, but instead we just look at a cross-section, at an asymmetrical cross-section, and we try to find the direction of the principal axis as well as the product of area. Okay, so compared to the usual set of axes that we would use for a cross-section, in this case, we have x and y instead of z and y, right? So we have the centroid, which is given to us as being here, and then you have the y-axis and the x-axis going this way, and then we have to find a couple of things. So this is the kind of question that you could see as generally a second-year student doing some form of engineering regarding structural mechanics. Right? And if you have any similar problems that you'd like to see on the channel, let me know in the comments. So what we are dealing with here is an L cross section, and we have all the dimensions and everything. And then we have to calculate what is basically IXY. And after we find IXY, we have to find the direction of the principal axis, and then we have to find the I x prime and the I y prime with respect to those principal axes pretty much. So let's see how we can do that. So the IXY is relatively straightforward to find. We just have to find the centroids of each section. So if we split, let's say, the cross section in two parts like this. So we have one tall rectangle which has a centroid at 6 centimeters from either end, right? So we've got IXY equals, and then we have the area of the tall rectangle, which is 12 multiplied by 2, so that's the area. And then we have to multiply that by the x and the y coordinate. So the x coordinate is given to us by this distance. Right, so the distance between the two centroids. So we know that from the left to the centroid of the whole thing we have 2.33 centimeters, and then we have to subtract 1 because that's where this centroid is horizontally, so that's 2.333 minus 1, so that's the x coordinate, except in our case it's going to be negative, so because it's measured to the left of the main centroid. So I'm actually going to reverse the signs and put the minus here and the plus here, and then this is also going to be times the y coordinate of the centroid. So we've got that from the top to here it's 6 centimeters, and from the top to the main centroid is 4.333. So again we subtract one from the other, so the result is going to be 6 minus 4.333. So we'll do the same thing as before because it will be a negative value, right? So this point is underneath the x-axis, so it will be negative. So we have a negative value here, we have a negative value here, which means that the IXY for the, let's call this section just 1. So the IXY for the first rectangle is going to have a positive value because both coordinates are negative. And when you multiply them, you get something which is positive. So IXY, and 1 is going to be equal to, and then we have the x coordinate being 1.33, and then times 6 minus 4.333, and then times 24. So this one is 53.33, and that is centimeters to the power 3. So that's the first moment of area of the tall section, and now we're going to do it with we're going to do that for the second section. So that is going to be as follows. So the new rectangle, or the second rectangle, is this one. right? And it has a side, not of 8, because this side we put it on the tall rectangle. So it's going to have one side of 6. So this is 6, and the thickness is 2. So the area is just 6 multiplied by 2. And then we have to figure out what are the coordinates, right? So we have the centroid being here. So let's try to figure out the x-coordinate with respect to the main centroid, of course. So we have the following. So from this end to here, we know this is 2.333. So 2.333. And then also from here to here, we have 2 plus 3, so we have 5. Right, so then it's the difference that we're after, and it's positive because this point is to the right of this point, right? So it's 5 minus 2.333. So that's the x coordinate, and now we do the y coordinate. So the y coordinate is going to be given by this. So it's 4.333 minus, and then we have to subtract the coordinate of, or the distance from the top to here, which is 1. So that's going to be 4.333 minus 1, and that equals, then we have to do this. So 5 minus 2.333 times 4.333 minus 1, and then times 6 times 2. So that is 106.67 centimeters to the power 3. So the total IXY is just the two of them added together. So we have 106.67 plus, and then 53.33. So that is roughly 160. 0.03, but we'll just treat this as actually, I think all those units here are not the right one. So this is centimeters to the power 4. Right. So 160 centimeters to the power 4 is the final answer for the IXY. And now to find the orientation of the principal axis, we have 2 times IXY over IYY minus IXX. So this is 2 times 160 over, and now the question actually tells us what's what, right? So just get rid of this. So IYY is 172, and IXX is 492. So we're going to end up with a negative value here. So it's 320 over, and this is going to be minus 320. So it's going to be equal to minus 1, which is a nice round number. So if tan of 2 theta p is equal to minus 1, it means 2 theta p is equal to minus pi over 4, or minus 45 degrees. So theta p is minus 22.5 degrees. So the orientation of the principal axis is 22.5 degrees clockwise, because we're in the xy plane, and minus means we're going clockwise, right? So we've got y going this way, we have x going this way. So now we're going clockwise by an angle of 22.5 degrees. So the final axis, the principal axis, are going to look something like this. So this is going to be y prime, and this is going to be perpendicular to y prime, x prime, approximately, right? So this angle is 22.5 degrees. So about this set of axes, we will have no product of area. So the ix prime y prime, so the new ix prime y prime will actually be equal to 0. So let's find I min and max using the usual formula. So that's ixx plus I, y, y over 2, and then plus or minus, and we have square root of I, x minus I, y over 2 squared plus I, x, y squared. And we end up with, so the first one is the mean between the two, so 492 plus 170 divided by 2, so this is 332 plus or minus, and then we have square root of, then we subtract one from the other, and we divide by 2, and then we square it. So I'm just doing this step by step. So 25,600 plus, and then IXY is 160 square, so it's the same number basically. 25,600. So this turns into 332 plus or minus 226.27. Okay, so Y min is 105. So we do the minus 0.73. Remember, this is centimeters to the power 4, and I max is going to be 332 plus. So it's going to be 558.27 centimeters to the power 4. And we can kind of look at it and guess from inspection which is which, right? So if we look at the y prime axis compared to the x prime, so it looks like if you look at the x prime, there's more stuff, there's more area away from the x prime, which means that this corresponds to I x prime, and this one is I y prime, like this. And that is it, basically. So this is how you find the direction of the principal axis, the product of area, which again is measured in unit to the power 4, and then that's how you find the minimum and the maximum second moments of area. And that's the end of the question.